Hello everyone, my name is Mahsa and I'm glad to present our paper on semi-automated time window detection for data-driven simulation, which we use process mining and system dynamic together. Process mining as a set of data-driven techniques helps us to work on the historical data of our processes inside the organization and come up and discover with the running processes, as well as assessing if the running processes is following the process that we had in plan. And also it helps us to have some enhancement on top of the our processes. So most of the process mining techniques are mainly backward looking. It means that we have the historical data and we try to fix them and work on them and detect what has happened. But the important part in process mining is forward looking as well. So there are two main directions in forward looking in process mining. The first one is simulation, which people mainly use discrete event simulation. And this type of simulation needs in-depth knowledge of the process. The other direction is prediction, which people mainly use using machine learning techniques, and these are for short-term predictions. In the simulation techniques, there exist several other techniques that helps us to go for more beyond the in-depth knowledge for processes and instance level. So for example, using system dynamic modeling, we can model our systems, and here in our problem, we can model our processes at higher level of aggregation. It means that we don't need to go in the depths of each instances in the processes, each cases in the processes. We can take a look at the whole process as a whole system and discover the variables that influencing each other or get influenced by other variables. In the system dynamic modelings, there exist two types of diagrams. The first one are causal loop diagrams, which we use to show the relationship between variables. So as you can see, we can see the relationship, how the variable bears affecting the value of population. The other type of diagrams here are stock flow diagrams, which we use to show the same relationship in causal loop diagrams, while we have the backend and underlying equation for calculating the values. Here you can see we have stocks like population, and then the flow of births add to the population and the flow of deaths remove from the population's value. So our general framework is starting with an event log, and then we do some pre-processing on top of the event log to make the data ready for having the simulation model. And then we use this prepared data, which we call them still log, to do the simulation and further steps. So if you want to take a look at an event log looks like this as an example. So this is an example of call center event log. You can see, for instance, this number 10 is a customer number 10, that a specific activity has happened with a specific resource and in a specific period of time. And again, if you take a look here, we have again customer 10 for the next activity and same attributes. We change this data to take a look at the data at the other level and other aspects. So for instead of taking a look at each event like customer 10, we take a look at each day of the process and calculate several attributes on top of that. Now, the important part here is that we here take a daily as a time window. So what should we do with taking this time window? How we decide which time window is the best time window to pick up? It's an important decision. Why? Because we end up with the variables on top of time windows, and these variables are going to be put in the simulation model. And after that, the simulation model should be able to run as a valid model and also provide a valid and accurate result. So it's very important to pick the time window that each time window is similar to the previous, or at least show stable behavior from the process in that time window. For that, we propose this time window detection framework. We start with an event log and a set of logical unit of time, as well as users provided time window, which can come from the background knowledge. We generate several ST logs or simulation logs for each of these time windows, and later on we focus on them to take a look if there is any trend on the time series data that we extracted in ST logs, and further on we use our technique to remove any inactivity in the time. These refined data can help us to train a model, a time series model, which can be any model. And here we use ARIMA model. And these forecasting values help us to see that how the model is good. And if the model is good enough, so it means that the time window was good. So among these trained model, we use the best model and the time window, corresponding time window to generate our final still log and doing simulation. Here you can take a look. If we define a sigma as a sequence of real values as a time series, so by taking a look at the time still log that we have, we can see that each column for us is a time series. So technically all the possible time series analysis is doable on top of our still logs. So our framework, as we discussed before, contains several main important steps. The first one is detecting the behavior. We use correlation and partial autocorrelation to detect the behavior of the variables. It shows if there is a strong pattern inside our data. And after that, we use the pattern to remove the seasonality out of our time series, as well as removing any trend inside the data. So now we have a stable time series data, which represent our process over step of time. And then we use this data to train a model like ARIMA model. And these models, the quality of these models and the level and amount of error shows us how the models are good. So the most important part of this work focus on the top level of this figure, as you can see. So we have time window selection, and for pattern detection, we have to detect the trends and remove them. We use several techniques here, and also we have to detect seasonality and also detect the strong pattern out of this seasonality. Then we pick the best time window, and then we use the forecasting, and the error measurement will tell us about the quality of our time window. For example, here you can see it in BPI Challenge 2017, you can see an example that we have each 7 days, we have a regular pattern in arrival rate. It means that each 7 days we have a periodical pattern that happens in our process. So for the evaluation, we've used synthetic data as well as real event log like BPI Challenge 2012 and 17, and we trained some models, as you can see here, for instance, and then we simulate using our data in 2 different time windows, and we compare the errors of these simulation results to see which time windows is the best one, and also we compare the selected time window here with the recommended time window, but by our approach. Here's the application that we have developed, and you can access the application via this URL. And we would be glad if you have any suggestion and idea, please write us. Thank you for your attention.